I think we can start the stream. Let me just first check that everything connected properly and everything is working as it should. Give me a moment. Okay. Looks like everything is okay. Hello everybody. For today's stream I have planned to model this Takanuva stuff that you can see on screen. This time I'm a little better prepared than the last time we did a modeling stream. I have a camera setup, and when I need to show you something on the part, or if I want to show you how I take some sort of measurements directly from the part, I will be enabling the camera. But unfortunately, because of Instagram's sort of weird resolution, this is the only way I could do that. So when it's not needed, so you can have better view at the program, I will be disabling the camera, and the screen will flip on its side, the same way I used to do this on Instagram so far. And if I want to show you something, I will be enabling the camera so you can see what I'm doing with my hands. So don't get frightened when the screen flip. You just have to flip your phone, and I think it will work pretty well. So let's turn this off for now. Let's just focus on the screen. I have loaded up references on the screen, flat scans of the part. I have both sides, because when I scan, I do this in batches. I don't really check first if I need the other side or not. I don't think we will need the other side for this part. I think it's symmetrical. We'll see. I already scaled the references and turned them the right way up. So we have that all done. If you are curious how I do this, I explained it in detail in a previous modeling stream, so you can check it out there. I already started drawing the profile of the part. That's because I initially didn't plan to model this part on stream, but again, a lot of this sort of thing is explained in the previous stream. So if you want to actually learn how I do this and try it yourself, you can check out that stream. Before we start, I will also mention if there are any new viewers that every hour I will have to reset the stream. That's because a program I'm using is connecting for only 1 hour. So again, I will try to remember about it and warn you before I disconnect and remake the stream. But if I forget and the stream suddenly disconnects, again, don't be scared. That's normal. You just have to reload a page, reload the stream. Maybe give me a few minutes before I have time to reload the stream, and we will continue. I'm not sure if we will be able to model the entire part from start to the end. This part is a little more complex than the part we did last time. It's not super complex, but I'm not sure how much time it will take to make the entire part. But that's okay if we don't finish it. Again, you have the last stream to check out the full process. I might also do this part in two streams. Maybe I will finish this part tomorrow. I'm not really sure. Also, I want to see how many people will show up, because if there isn't big interest in this sort of thing, I don't think I will be spending more time on it tomorrow. So we will also kind of see how it goes. And the other reason for today's stream is also I want to try to maybe tell you a little what's been happening behind the scenes with me lately. I wasn't very active on my Instagram account for Bionicle, on my AOSM account. I was posting some stuff on the main account, on the AFC account. So it's not like I've been completely inactive for months, but if you only follow the Bionicle, the Lego account, that's the impression that you might get. So I want to kind of explain what's been happening, also how it's going with the shop that unfortunately is still closed after what is it? Half a year already. So it's closed for a pretty long time. I didn't plan it like this. I didn't know that it would be closed for so long. So I want to also tell you kind of about this. I know there are some people that are waiting to make some purchases. I've got messages from you guys that you are waiting for me to open the shop. I know about it. I really appreciate it, and I would like to open the shop as well as soon as it's possible. But it's kind of complicated situation. I'm not sure if I will be able to open it soon. So I want to tell you the story about it. Also, not sure how efficient we can model the part with me also talking about some stuff. So this is more of a hangout stream. If you want to see the entire process of modeling, I again refer you to the previous modeling stream. Okay, so let's kind of start. Let's keep it rolling, and when we get a nice pace, I will go back to the personal stories. Okay. I will be doing some commentary on the modeling, just not to have dead air. But again, I think the process was pretty well explained last time. So maybe some oddities here and there I will explain, but generally, I think I don't need to. Not really. Okay, is this line tangent to this? Let's see. Not really. Also, interesting thing. You have to be really careful with your scans, both when you do them and when you use them to draw the references. With this kind of zoom, you can think that they're both well made, good quality, and you could use them. But if I zoom very closely on the pinholes, you can see that this line and this line should be one on the other, should be aligned. But we can see the sidewall of the pinhole. That means that, well, if it would be a picture, there could be some perspective distortion. But because this is a scanned part, we know that it's laying flat, and the scanner, which is basically the camera that is taking this picture, is perpendicular to this part. So where this sort of distortion came from? It is very possible that when I lay the part flat on the glass of the scanner, and then I close the lid and touch of this white background on the part, it's possible that I squeezed it and touched the part, and it very delicately rotated. So the part isn't laying flat on the glass. Fortunately, this side came out very well. We don't have this sort of distortion. You can see that all the walls are perpendicular to the scanning glass, and we can use actually this reference. So the entire scanning process, making reference process, requires you to be very precise, very diligent, looking for this sort of things, and well, the perfect way is to avoid making bad references. But when you accidentally make bad references, you have to either remake it or be aware of it while drawing to not introduce some sort of error to the model you are making. So we'll be mainly basing our reference on this scan, and using this scan only to look for some minor differences between two sides, but I don't think we will even need this side. Okay, so we know that these two lines are perpendicular, or parallel rather, so we can draw this freehand like that. Okay, we have a closed profile here. Let's cut off here like that. Okay, there's this nice curve that is tangent to this line, and I'm wondering, it also goes through this point, but not necessarily. We don't know if it actually ends here, so let's extend it, maybe like that. Okay, so which thing we should start with first? Maybe let's start with the circle. First, let's measure it and find the rough position right here. Now we want to be the circle to be tangent with this line, so we can slightly move it. Again, doing a little hack job because lack of commands that would let me do it the perfect way. But on this scale, this kind of precision is perfectly fine. Now we need to, okay, I think this arc will also touch off on the point where this line and also this line cross. Actually, let me look at the part real quick. Okay, so this arc is indeed tangent to this line. It also touches off on this edge, so I was correct there. Also, I can touch off the part on some flat surface on this edge, and I can see that indeed this edge is moving away from the reference, so I can also confirm it this way. Okay, this section is a little thinner. Okay, let's get back to our program. So let's draw this arc roughly. It goes about, actually, if we make this line first, we will have the connection point. Okay, like that. I see some people are joining the stream. Hello, welcome. If you have any questions, you can type them in chat. I don't have the chat permanently on screen, so it might take me a while to get to your questions. But if you are curious about something, you absolutely can type out your questions, and I will get to them in some time, and I will answer them. Okay, so now we know that our arc will start here, go somewhere through here. Now it needs to be tangent to this line. Again, it would be great to have a command that let us choose this the circle and say that it's tangent, but let's just find a rough place where they meet. And now we know that it's not actually tangent, but we have a rough radius of this arc, so we can measure it. It's 4.81. So let's delete it, and now do the tangent radius circle, tangent 4.81. Yeah, that's the problem with doing it this way. It doesn't always work. How to do this? Good thing that this arc is in tangent with this line, because then it would be an absolute nightmare. But with it going through the point, it's also pretty difficult. How to do this? 3 points, center, start angle, central angle. Start and radius would be useful here. And unfortunately, nanoCAD is sort of limited with this sort of thing. I think we will have to sort of cheat on this being tangent here. Again, on this scale and with 3D printing, it won't be even detectable. The only downside to this method is that I personally know that it could be done a little better, but the part will be perfectly fine, and in the end it won't really matter that much, so we can leave it as is. Okay, like that. Or because this what do you call it? Offset. This offset will be done all around the blade, but we want also this offset to go through this point. So the offset needs to be equal to this distance, 1.36. Let's try if it will work this way. So the offset length is this, and this obviously works here and here, but does this work here? Yeah, it does. This here. Okay, so we can use this offset line. It's kind of a shame that it's not really a nice even number, but it matches the reference well What's the radius here? I can see on this background 0.4. So let's do fillet 0.4 here and here. Okay. I also have a lamp set up for the camera, so you can see the part and the calipers, and the lamp shines on my monitor, and it makes it kind of hard to see. Do we need some sort of radius here? Not really. So we can leave it as is. Cut off here. Actually, this stays. Okay. AutoCAD had this sort of thing that when I moved the view, I think it was because of the memory running out, the picture would vanish, and I would see only the lines as long as I drag it from side to side. And it was really useful to kind of see the lines without the background reference. So it was sort of a bug, and something that wasn't really supposed to happen in the program, or it was bad that it was happening, but I learned to use it to actually check if all the areas are outlined and if I have everything now. The only way to do this in this program is to delete the picture and then go back. So we have to do the teeth and the holes in this blade. I will be skipping the ejection ports from the molds, so let's maybe do the holes first. Are they on some sort of a curve? Those three look like they are. I don't know how about this one. Maybe let's see. Center. Oh, it actually worked. Interesting. Okay, so they are on the arc that is concentrical with this edge of the blade. Okay, so we just need to pick up the radius of this arc, and we will do this by finding the center of this first circle. Okay, right here, center of this, like that. They also look like they are evenly spaced, and because they are on the radius, on the arc, there isn't a distance between them. Well, there is, but we don't measure it like that. We need to find out the angle between them. So let me see. I can't. I always don't remember if we need. What do you call it? Odd number of the objects or even number, and because with one of those two you can do nice mirror lines, and with only two objects do on any amount you want, but with the other you can't. So wait, let me see. If we do this, then we can make a center line between them. And if we make again center line, okay, so we need to do this one, I think. Yes, so we need odd number of things. So let's find center of this circle. And we are interested in the circle on in the center only, and we don't need the diameter of this hole. So let's find first the center of our arc, and now we have a point where those two cross. We don't need these two. And now if we take this circle, ensuring that they are both the same diameter, we can move this here. Okay, now we know that the angle between these two is twice as much as we need the angle between every object in this, I think it's called array. Yeah, array to be. So we can cheat with, again, finding circle center. Going to, oh, damn it. Again. Center. So here. Center. Here, and now if we find center point between these two, we don't need this, we extend this, and now we have our third position for our object. So we move this here with only 4 holes being there. This method may be a little overkill. This sort of drawing makes more sense when you have a lot more of the things in your array. But now when you sort of started and we have all the things we need, we could do this little trick that we take this hole, and we with the mirror command we can find the position of this pinhole, and if you would want to continue, you can again draw a line from this this hole to the center. We can click those 3 holes, and again with the mirror lines, with the mirror command, we can find another 3 holes on the same arc. So with this method, we could now, when it's all set up, we could draw a lot of the objects in the array pretty quickly. But we are done with this array, so we can delete all this helping geometry. Or wait a minute, let's back up, because the teeth are also on this arc, and they look to be in between those circles. So we can use it to use the previous array to make this a little easier. Let's see. Okay. What shape are they? There's a triangle with rounded off tip. Looks like those sides are straight. There's a little fillet here, but I don't think I will be drawing it. Maybe I will. Let's just see. Okay, so let's start with one side, like again, maybe here. Okay, like that. Let's do the other side independently. And now if we mirror this, why didn't it work? Oh, I clicked offset instead of mirror. Okay, again, this mirror here. Yes. Okay. Are they this close? Or are they the same line? No, they are. Look how close they are. That's amazing. I've never drawn anything this precisely. What's the distance between them? It's gotta be like microns. It's genuinely amazing. Oh, come on. Why can't you? Oh, okay. I see what's happening here. What? Stupid program. Maybe like that. From here to here. What was it? It's 0.00. I'm looking here at this value. It's 0.0008 millimeters. So it's 0.8 of a micron. It's amazing. Okay, so I won't be actually finding difference between them. I'm going to treat them as the same line. For a reference, for those who are unaware, I think the thickness of human hair is few microns, or actually, let me Google that real quick. Thickness of human hair. .70 microns. So 0.07 millimeters. And we got 0.8 of a micron. So 70 divided by 0.8. The distance between those two lines was 87 times smaller than a human hair. It's genuinely amazing. And also it kind of shows the how little matter all the shortcuts I'm doing with the lines being tangent and with the points meeting. The scale here is so tiny that those sort of things are really insignificant and won't be even detectable on the finished part. So you kind of need that perspective to know what shortcuts you can and which you can't take. Let's see, the diameter is 0.23, let's say. Let's do 2.5. 0.25. Let's see if it looks right. No, not really. Will the 2.3 look better? 0.23. Or did we screw up the measurement? Kind of better. It looks okay. This here is a reflection, so you can see with this line that here is our corner, actual corner. Okay, so with this tooth being drawn, now I can actually show you the mirroring of the objects. So we take this tooth and now we can mirror it just like that, and it's in place. And now we can choose this tooth, and we can mirror them both on this line. And now already we have 4 teeth. There's only one more to go. And to get it, we need to draw some more mirror lines. Maybe let's do it like this. So it's a method. You could use the array command. There's a rectangular array, there's a polar array. So for some people it might be easier this way, but I like this method. It takes a while to set up, but when it's actually already set up, it's pretty easy to make a lot of new objects with it. And now again, mirror, and our last tooth is in place. Okay, so now we can get rid of all this geometry. Okay, we also need to open up the teeth here, 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 and last one here. Okay, so looks like this part of a blade is finished. So we need to make the middle section and the back blade, and we will be done with our two-dimensional drawing. Okay, so let me remember what was I supposed to talk. The shop being closed for so long. So the backstory or the situation that happened with the store was I got a new job that required me to move a long distance to the other side of the country. That meant I had to leave all my tools behind. I had to close my workshop, my place where I made all the parts where I work on my projects, and the hope was that I would close the shop temporarily. I would move to the other side of the country, and when I started the job, I would slowly bring my tools, set up everything again, and the shop would be closed only for some time until I settle down in the new place and open the shop back up. And I was expecting for it to be only a few months. So I expected that with the start of this year, I would reopen the shop, and everything would be back to the way it was before. Unfortunately, it kind of didn't happen. With the end of the year, I actually bought my tools and started making all the new parts that I developed in the meantime to add them to the shop. I started redoing all the stock of the previous parts, and I was getting ready to open the shop. And the plan was to open the shop with the start of the new year. Unfortunately, it kind of, like I said, didn't happen. Some stuff happened in my personal life, some stuff happened in relation with this new job. It takes a lot more of my free time that I expected it would. So kind of I was, like I said, I was getting ready to open the shop with the start of the year and didn't. So it kind of sucks. I'm not sure if I will be able to open it again soon, because I'm not sure if I won't be moving again soon. So right now I could open the shop, but I'm not sure if it would be open for long, if I wouldn't close it again in a month or two. So I'm kind of waiting on that to see the situation stabilize, to everything to work out, and then I would open the shop again. So like I said, I was getting few messages about that. People kept asking when I will be opening the shop, and letting me know that they are waiting on it and want to do some shopping and buy some parts. So I thought it would be a good idea to let you know that it was planned to be opened at this point, but unfortunately some stuff didn't go as planned, and I was forced to prolong the shop being closed. But I'm not giving up on it. I plan to open the shop again when the situation lets me. So if you are still waiting for some of the parts I made, please be patient. I will be opening the shop sooner or later. Unfortunately, right now I can't predict when it will be. I can't promise you anything, but I implore you to be patient, and I want to let you know that I also want to open the shop as soon as possible. So this is kind of how the situation looks and was with the shop, which is also related to the my activity on the account, with not as many projects being made, not as many posts. I didn't develop any new parts this year, and it's April is already coming to the close, so it's been some time. Like I said, this new job kind of requires a lot of time, so I've been kind of busy. I was posting some stuff to the other account, to the non-Bionicle related account. I made a few small planes since the start of the year. Come on. Give me a moment. My mouse malfunctions. I don't know what it is. I think the battery is low. God damn it. Do I even have a spare battery? I'm not sure. Okay, let's try to get through this. Yeah, so I was kind of busy with some personal stuff. That's why I didn't post so much Bionicle content. Also, this new job kind of it's a creative job, so it also requires from me a pretty high level of creativity on a daily basis. And with this new job, I'm kind of drained creatively, and when I go back home, I don't feel this big urge anymore to create new stuff. So also there's kind of this aspect of it that not only I haven't got. Why doesn't it work? Oh, okay. I both haven't got a lot of time to do new parts and new Bionicle content, but also it's kind of hard for me to in addition to being creative in this new job and meeting some of the deadlines and requirements, which when you do creative work can be really draining, because whether you like it or not, whether you have a good mood and want to do creative stuff, it doesn't matter. You have to, because you are getting paid for it. So definitely there's also this aspect that I've been kind of drained. Sounds kind of bad, but definitely my creative needs were met with this new challenge, that is this new job. So when I go back home, I don't have so much creative needs as I used to before. So I've been doing some lighter projects on the other account. The planes I made, the two planes were this sort of this little lighter on the creative side projects. Also, I did recently a pretty big and pretty challenging project, which was the island diorama. If you follow my other account, you might have seen it. It took about a month to make. It was a very special project because it was a gift for my father's 60th 60th birthday. So it was very special, and it had a very unmovable deadline. So I had to make this project before his birthday. Fortunately, I was able to do it in time, and my father really liked the diorama. So full success there. But again, it required me to put a lot of time and effort into it, in addition to this new challenging job that I had. So for the last month, every day I used to come back home, and I had to every day work on this diorama to meet this deadline of my father's birthday. So it also was kind of draining creatively, and the matter of the fact is that I don't have this sort of need as I used to creatively make new projects. I find it pretty hard to find time and basically work on these projects, put effort into them. I would much rather like to spend some free time on some other things. So that's kind of how everything has been looking beyond the scene, behind the scenes. So yeah, I'm pretty sure that it's not really good news for fans of my work, for people who want to see my work, to let them know that I'm not doing it, and I probably won't be doing it as much going forward. I realize that it's probably not what you want to hear, but I also wanted to be clear that that's kind of things go in life, and that's kind of the reality of the situation, that with me doing this for free and doing this with my own free time, I also have to put time into it. I have to put money into it, and the reality is that it doesn't pay bills, and it doesn't allow me to live comfortably. So unfortunately, in addition to this hobby, I have to have a full-time job to pay the rent, to pay for groceries, and unfortunately with these two things, with this hobby and with full-time job, unfortunately the full-time job is more important, and with those two things clashing, I unfortunately has to choose the full-time job. So this is how it looks. I would love to do this entire project, both Bionicle related and all the other stuff, full time, and be able to pay bills with it, but it's not something that I can do right now. So unfortunately, this is how the situation looks, and that's the explanation of what's been happening recently. So that in summary, if you are waiting for the shop to open, please be a little patient still. I think it will happen. I'm trying to do this as fast as I can to open the shop for the people who are waiting. As for the posts and the amount of creative work I'm doing, unfortunately, you can expect this sort of decline and a little less work being done from me, and smaller amount of posts and photos and new parts being developed, and this is kind of how unfortunately it must be. Although I'm thinking about expanding my projects in some new ways, doing some new stuff that I haven't done before. I don't want to tease anything because it's a pretty big possibility that I won't be able to find time to do this. So I don't want to make some promises now and then let you all down. But if I had indefinite amount of free time and all my all my bills were paid. I think I could do a lot more, a lot more interesting stuff also. So if the situations improves and I'm able to find a little bit more time and my financial situation is a little more stable, then definitely the amount of work and the quantity of projects will improve with time. So if you like the work I do, if you like seeing the things I make, the things I design, I just implore you to be patient and give me some time to figure stuff out, and I think that with time, as the situation becomes a little more stable, I think I will again start to post some more interesting, some new projects in bigger quantity. So just be patient. With that being said, we are almost at full hour. So to not get cut off in the middle of a sentence, I think I will reset the stream a little early. I I realized that with me talking about one thing and working on the other, I've been being a little slow. So with the all the behind the scenes stuff being explained, I think with new hour I will try to focus a little more on the part, so we can model it today fully. So give me a few minutes, I will reset the stream, and then we will get back to the proper work. Okay, everything looks fine, so we can get back to work. Okay. So, with this teeth, we have a similar situation as with those holes and this teeth. Again, we need to find the shape and the position of the first one. We need to find the position of the third one, or the biggest odd number which we can. We have 4 teeth, so the 3 is the largest odd one. So with them two, we can find the middle of them, which with odd number of objects will always turn out on one of them, not between them. And now we can to copy the first object, we can again find a mirror line between the first one and the next one, like that. There we go. Here and here. So here is our center line. Maybe let's keep it marked for later. Okay, so this and this mirrors on this line, and there it is. And again, we could find a mirror line between these two and mirror this one, but between these two, the first and the third one, the second one is already a mirror line, so we can use it. Mirror the first appearance of the object. Here we have first, second, third. Now we just need the fourth one, and again we could find the line here, but we can use this line. So this and this mirrors to it didn't work again. This and this mirror here, here, no, and it worked out fine. So now we can get rid of all the helping geometry. I think we messed something up here. This one looks fine, this one looks fine, and this one looks fine. So the fourth one, for whatever reason, didn't work out. So we will have to... I misclicked somewhere. It's very likely, so let's remake it very quickly. Also, the talking about some other topic while working proved to be a lot harder than I imagined. So if I want to focus on the work, I really need to focus on it. It's sort of doing one thing and talking about the other stream is a lot harder than I thought it would be. And I think I need a lot more practice to make it work. So let's for now focus on the part. Okay. How this corner looks on the part? Let us have a quick look. It is actually this sharp. Let me have some pointer. It's right here, and this line is actually rounded over, and this line is straight. So you could have some fillet here, but it would be a very complex surface that would wrap around the round off here. So it's pretty understandable that they didn't do it this way. So we can leave it sharp. It's the same way here. I noticed a moment ago that this region is pretty dark on the reference, so I'm making sure that I know how it looks there. Also, this circle is raised here, so we need those two lines left there. Is it anything more interesting here to check out? I don't think so. Also, let's look at the both sides of the part. Let me see region by region if there are any differences between the left and the right side. The back blade doesn't, the middle doesn't, and the main blade also doesn't. So the part is perfectly what do you call it? No, not mirrored. What is it? Symmetrical. Both sides look the exact same way. Okay, so we can set it aside for now. We can get back to modeling. Okay, so this corner looks like this. Those two lines stay. This will be rounded over, but we don't need to draw anything special here. All the part numbers and copyright info, we don't really need it. The same time as the last time. There is a little, very tiny round off here. Let's do this with 3 point. Let's measure it first. Around, let's maybe say here, here, like that. 0.15. Let's maybe do this TTI. Here, 0.15. Okay. So definitely don't need this. and don't need this. And this, because it's raised, stays. Okay, we also need 0.15 here. So again, TTI, here, 0.15. Cut off this and this. Okay. Man, that's one dirty part. But don't be so grossed out. I think this is some epoxy putty. It has a pretty disgusting color, but it's not any sort of gunk. I vaguely remember trying to cast this part with some putty or enhance it or modify it. I'm not really sure, but it's just plastic that has this pretty ugly color. Okay, how does this look here? This is a sharp corner. Okay, so this stays like this. We actually can see the corner here. So let's pick this up. Actually, I'm curious. Those two angles look like they are mirrored. So let's maybe try using this already existing line. Again, it doesn't really matter. No one will be even able to measure it, but just to make things consistent for our own peace of mind. Okay. Let's do 0.15 here. There's a line. Okay. Cut off this, and this. TTI 0.15. Or maybe something a little bigger. What was the radius? We did some radius, but I don't remember here. No. Oh, at the tips. What was it here? 0.23. So let's maybe try this. TTI. I keep saying TTI and I'm not sure if I explained it. So let me just finish this real quick. There are few different ways you can specify well any sort of geometry, but specifically circles. You could, for example, the most standard way is circle by center and radius. So you pick up 2 points. The first one is the center of your circle, and the other one will be at the circle, at the perimeter of the circle, and the distance between those two will determine the diameter. So like this. The other way, you can see it here, draw circle, it was this center radius, there's also diameter. So it's pretty similar. The first point is center, but the second one, oh no, so this is 2 point. So why isn't it? I thought it's because the weird thing in this program is you have some comments here, you have some comments here, and they don't really match up with name, and there are some comments here that aren't in here, so it's pretty weird. The second way to specify it is diameter. So you first click a point which is a center of the circle, so the same way as the first one. But now if you type diameter, or just D right here, and click enter, you can see that the radius of the circle is at the half of the distance I'm drawing. So now we don't specify the radius, but we specify radius times 2, which is diameter. So that's what I thought the second command is. And what it actually was, diameter, that's what I thought it was. But actually that's what's called diameter here. Right here is called 2p, so 2 points. And if I type 2p or just 2 and click enter, the first point is at the one farthest place on the circle, and the other one is at the other farthest place on the parameter of the circle. So again, we are specifying diameter here, the same as we did with the second one, but the points which we specify are in different places. So this method is very handy to specify middle between any 2 points. I pick the first point, I pick the second point, and now the center of the circle is at the middle of them. So I use this method pretty often. And here it's the last one, and here it's almost the last one. TTI exists only here; it doesn't exist here, for whatever reason. Again, okay. So the next one is 3 point. If I choose the circle and I type 3 point, 3p or just 3, enter, I specify the circle with any 3 points. So here, for example, here and here. It might look a little wacky, but it actually gets pretty simple if you realize that you are just specifying a circle that's inscribed on a triangle. So here, here, and here. So it's pretty basic geometry. And the last one, the one that I keep using and mentioning, is TTR, which stands to tangent radius. And we need 2 lines to specify this this circle. And when I choose circle and type the full command TTR, or just the start, which is T, I need to specify 2 tangent lines, so this one, and now I specify radius. I can either type in radius or pick it up from the drawing. So I can, for example, say that the radius is this long and the circle appears. And to really show you how it works, I will do this one more time. TTR, use the same tangent lines, but now I will make the radius smaller. And you can see that the new circle is again tangent to those lines, but because the diameter of the circle is smaller, it's in a different position. So you can see that there are 5 different ways to draw a circle. Here there are also arcs, which kind of work like a circle, or you can start with a circle and then convert it into an arc. Other way around, I think it's pretty difficult, because even if you close an arc, I don't think it becomes a circle. I think it just I think it's always an arc, even if you connect those 2 points. I don't know. Anyway, so there are many different commands that you can choose between to match your needs in a particular moment. And the funnest part about this is the thing that I keep complaining about, that this program has too little, not too many, but too less, not enough ways to draw circles and arcs, because AutoCAD, which I keep referencing, has probably twice or 3 times as much different ways to draw circles and arcs. So that's what I keep referencing when I mention TTR. Okay, back to the drawing. Those 2 circles, this one and this one, look pretty similar. Let's see if they are the same. They are. So we can use those, but first we need to find the exact center. We do that with 3-point. So let's say about here, here, and maybe here. We have our center. We don't want the circle here. We only care about the center. Now we can move our 2 circles in the perfect place. Don't need this. Okay. What is this shadow here? Let me look at the part. Oh, come on. Zoom. Oh. It's this place here, and there is no additional line or wall here. I'm not sure what that is in our scan. I think it's just a reflection. Okay, no idea what happened there. Got to do everything, basically all my layout, all my streaming layout from scratch again. Really sorry about that. Got some major technical difficulties, so sorry. I think now everything will work fine. Thank you for your patience. We can continue with the stream. Okay. This goes like that. Oh, this really needs to be touching this. Okay, so let's move it a little. No one's gonna know. I won't tell anybody, you guys won't tell anybody, so this works fine. Okay, so this line ends here. No, it doesn't. But this one ends here. This one ends here. This. Come on. This. Okay. Let's see. Okay. What was the offset? Maybe let's do the outline first and let's do the offset later. Okay. I think this will be smarter, so we can do this arc here, here, and let's say here, like that, and this can end here. Okay, so we can extend this to here. Now we can cut off this line. Okay. Also, we need a line that's tangent to the circle around here. Okay. Maybe let's do the offset here. Oh, it looks like it drops off. So they aren't really concentrical. We have to do this freehand. Okay. Like that. Can we do some offsets now? I wonder if we should round this off here. I'm looking at the part. Let's see. It's this corner. I think we can do a little or no, it's the same as it is here. There's a flat that's parallel to the longer line. Okay, so no fillet, but there's a, wait, where was it? Here. Yeah, you can actually see that it should be the same way as it is here. It's a little less visible, but that's how it's supposed to look. So this will go around here, like that. Okay, we can do at least some offsets now. Okay, so the offset was from here to here, and we can offset this to here, this to here, this to here, this to here, and let's skip the ribs for now. Okay, so I think that's all. Let's cut off the excess. This, and this. We kind of fell out of the part a little right here. Again, this could be caused by the distortion with the scanning. The part might have rotated a bit. Okay. Everything. Oh, here we have some weird thing to address. Okay. Oh, so we just need to extend this like that. Now we just need to add the ribs and we will be good to go. Okay, does the ribs all point to the center of this arc? something didn't work. Let's try this again. Center of this. Kind of, but not, no, not really. But maybe to the center of this arc, because as you may remember, they are not concentrical. Center, let's see. It's not a lot better. It's a little tilted. But maybe to this arc. No, definitely not. Okay, so it looks like they are independent of those arcs. So we can draw them freehand and find our center by ourselves. Instagram is acting up again. Give me a moment. Jesus, I hate this platform. It's nothing worse than Instagram. What a piece of shit. God damn it. What a piece of shit platform. Okay. If anybody knows a better streaming platform that there are no problems entering, like Twitch or some other platforms, you don't need a big number of subscribers like you do on YouTube, and the one that's easy to get onto and easy to stream on, please recommend something to me. Please let me know, because I can't deal with this piece of shit platform. Fucking Instagram. God damn it. Okay, anyway, here's the center of our arc that all the ribs are based on, that are spaced on this arc. So it looks something like this. You can see that it doesn't match none of the arcs that we have so far. So we actually did have to do this way. What is this? Why do we need this? Who do this? Go away. Okay, so now 1, 2, 3, 4, 5 ribs. Okay, so now I remember that we need an odd number, so we can do the first one and the last one, and this will be all that we need to fill all the what do you call it? All the ribs in between. But actually right, those two lines were only used to find the center of the circle, but they aren't actually at the same angle that the sides of the ribs, because sides are supposed to be parallel to each other. So we need to find now another line like this, and you can see that they are at an angle to each other, they aren't parallel. And now let's add this circle to help ourselves out. Find a center, like that. Okay, also we need a center between this and this. Now we don't need this or these two. Now we have the center of this ape. If we mirror it to this line, oh, I think so. No, it went okay. I think something went wrong, but everything works out. Okay, so now we have the center lines of the three apes, the ones at the ends and the center one. And now we need to draw the sides of the apes, which aren't parallel to the center line. So let's freehand it. Let's do one like this. Let's pick up the same angle and just find the distance. It's about here. Now let's split the difference. Again, they are very, very close. Now we can mirror this one. Okay, and we have our first ape. Let's extend this a little. And now we can mirror those two lines through this line. And we have our end ape, the last one. Now if we find a center between those two, we can mirror those two lines on this line, and we have one more ape. Okay, and now we can mirror this line on this line. Wait, did I mess that up? No, because we can find center line between those two. And now mirror these two. I know it looks a little crazy with all the different lines, but if you actually sit and do this method 100 times, it actually becomes pretty clear and pretty logical. Okay, now we have all the apes, so we can get rid of all that. Don't need this. Now let's do the trimming. Okay, the lines don't cross here, they crossed here, so we need to extend them here, like that, here and here. We can do some more taming. Let me turn on the camera. I'm looking at this place. If we should leave this line here, let me see. They are smooth, but because this region is flat and this one curves down, we actually need this this line here to cut off these two regions, even though there is no tooth here, it's all flat. So let's leave it in place. It will make things easier on us later. Okay, we can get rid of that. Now we need to do some fillets here and there, and we will be done. Okay, here's a nice big area we can measure around here, and it is 45. Let's do 0.45. 0.45. Like that. Here. 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 Those angles stay sharp. Like that. Oh, messed it up. But also here, but yeah, the radius here is smaller. So let's fix that real quick. Okay, and let's try 0.15. Yeah, it looks okay. Maybe here. We could do one here and one here, but how does it look here? I think those are the equivalent one. Okay, so let's do them on both sides. So here and here. I lost it. Again, here, here. Here we are already done. Oh, we lost an arc here. The radius tool, the fillet command, sometimes I talked about it last time. Sometimes it cuts off, sometimes it doesn't. You can actually change it here. It's the scissoring. I don't know, it's not a command, but line aspect. Oh, aspect is a good word. Aspect of the command, and sometimes you tell it to cut off and it does. Sometimes you tell it to cut off and it doesn't. Sometimes it works the other way around. So I explained last time that I sometimes get weird results with this command. Okay, I think that's all. Let me quickly check without the picture. I think we are done. So, we have to reset the Steam real quick. We started it a few times, so it actually could go for some more time, but I'm not sure when it will end. So let's quickly restart the Steam, and we will start the 3D modeling part of this task of today. So give me a moment, I will reset the Steam. If you want to keep watching, reload it in a few minutes and we will continue. Okay, we are. So we can start the modeling. Here we have opened Fusion. Like last time, let's import the flat reference that we do. Where are we? Wait. Here. Okay. Here's our part. Okay. Let's rotate it and move it. So first let's rotate it. I haven't used Fusion in few months. I actually do 3D modeling in this new job I mentioned, but we use SolidWorks there. So for a few months I've been using exclusively SolidWorks. It's a really great program. You can do a lot of cool stuff there, very professional with many different options. But the downside is that it has some different controls and different commands. Well, basically the same, but they are called differently. So now with going back to this Fusion Inventor environment, I'm kind of lost. So give me a moment to readjust. Where's the move command? Modify. Why can't I move it? Was it M? Yes. Point to point. There we go. Okay. Now let's mirror it. Where's the mirror command? Come on. Not this one. Yeah, that's exactly what I'm talking. I'm a little lost. Origin, I think. No, that's not what we want. Damn it. And I also was never really that familiar with Fusion in the first place, since I always worked on Inventor. They are pretty similar, but there are some minor differences. So with not using the Fusion much in the first place, having this many month break, and in the meantime using also a different program very frequently, because every day at work I'm kind of lost here now today, so forgive me. I'm going to open my dimensions. Okay. Let's save our progress. Whatever. Okay, so now let's turn on the camera. Here's our part and how I want to approach it. I think I will do this the same time I did last time, which is to create the most complicated and difficult geometry first. There's this slope that has that goes down, but has a changing radius. It's not just a sweep, because the length here is much larger than here, and this is all a smooth surface that goes like that, and there are some holes punched through it. So first we need to create this smooth surface, and then we can punch out the holes, which will be the easy part. We have those round-offs here, which could be again made in few different ways. I think I will extrude them from here to here, so we have the rounding off done already. Then I think I will punch out this hole this way. You could also extrude it this way up and then add these round-offs, but I think sweeping them, well, not sweeping, extruding them in this direction will be a little easier. All of this stuff can be extruded, it's pretty easy. And this blade, let's see. It's not actually the same situation as it is here. It's not a one smooth surface that has this big cutout in the middle. It looks like this long backside is actually straight. Yes, it is. This one is also straight. There's a little rounding off here on both sides, and this basically cutting edge of the blade is all one thickness. That's why they don't meet here. You have this head cutout here. That's because it's not the same geometry as here. Here we have one smooth surface, and this is something completely different. So this will be a little easier to make than this. Well, less complicated. It might actually give us more problems, so not sure if it will be easier or harder, but the commands used to do this part will be a lot easier. So I think I want to do this back blade first. I think I will do this with loft. Then I want to do this front blade. Then I might do this sweep, and then I will fill out this middle section with extrusions of all those pretty easy sections. Okay, so that's a good plan. And we can start. Let's turn off the camera. Okay, so the first thing is this. Let's make some helping geometry for ourselves. We need to do some profiles. Okay, actually I might leave the camera on, because I will be moving the part pretty often now that we are doing 3D modeling. So let's maybe leave this on. Let's see. There's this sloping off. We have nice clear profile here. This is all one thickness, which we can pick up from the part. And here is a little different profile than here, because here it slopes off from the very beginning, and here we have some flat section and then it slopes off. So I think we can do this profile, maybe add some rails here, here. Maybe we will get away with 3 rails, one here, here, and one in the middle. Or I think we don't need to risk it. We can, yeah, because this profile here has this little flat here. That's where you get this. Is it? No, it actually isn't. Okay, so we will have only one rail here in the middle, because we don't have a flat here. It's rounded off. The radius here kind of makes it hard to see. Okay, so we need this profile, 3 rails, and I think it will work out fine. Okay, so first we need a nice plane. Right here. Like that. We will also need all the places where the lines meet. So let's do this with a point. This point has to be on this line. Did something move? No. Maybe let's lock everything in place first. Maybe that's smarter. Okay. Now nothing will move. We are safe here. Okay, so this point has to be on this line, but also on this line. So here is a point where those two intersect. Do we have a fillet here? No, so we don't need to do this here. And again, here, this, here, and here. And we need another one here. On this line and this line. There are some points that will help us pick out those intersection points, which we will use to reference our profiles. Okay. So again, looking at the part, we have a straight line here. Then we have maybe like that, circle here, and an arc, one on this side, one on this side. This is tangent to this, this is tangent to this. And the circle is on the middle of this profile. Oh. Also, the center of the circles are on this line. This is construction, and maybe also do some mirrors just to be safe. This and this mirrored on this, this and this on this, and I think that's all. Okay, so now the middle of this line is on this point, the middle of this arc is on here, this dimension is taken from the part. Let's make sure our calipers measure properly, and the dimension here, let's call it 5. Can you see it? Well, is the camera set up properly? Okay, everything looks good. I don't actually see the view from the camera. I have the Fusion on full screen, so I had to check. Let's do 5, maybe 5.5. Yeah, 5.5. 5 and come on. 5.5. Okay. Something didn't work here. Or did it actually? Where's our point? Oh, okay. So like this. Okay. And we need to pick up this dimension here. And roughly it is, well, let's maybe do this. 1.45. 1.45. So this is how this profile looks. Okay, this one is done. Let's do a similar one here. Sketch. Again, we want to make the same shape here. Maybe let's turn this off for now, so it's easier to see. This to here, this to here. Okay, trim, tangent, tangent. Okay. Which one is the middle one? Okay, so this to this. Okay, this mirrored to this, this to this, this to this, and this on here. Whoa! Let's try that again. There we go. Here to here. Nice. Okay, which one was unmovable? I think this one? Or this one? No, this one. Oh, god damn it. I can't move it now. Where's the lock? Can you see the lock symbol? I think I locked this point. Unfix. Oh, okay. I didn't know you could do that. Okay, so now the geometry is constructed well. Let's now put it in place. Center of this is here. I think it was this one. Yeah, it doesn't move. So this to here. Okay. The dimension here is probably the same as here. It was 5.5, but let's double check. It's a little more. Actually. Oh, so the circle sticks out. So the circle is a little more, and this can be the same, 5.5. So this is 5.5. Okay, let's do the end, the same dimension we did here. What was it? From here to here. 1, 4, what was it? 1, 4, 5. One, 4, 5. Okay, we have the second profile. Now we just need to add our rails. So let's start with this one in the center. It will be the easiest to add. Okay. It's just an arc. It's tangent to this. It's concentric to this. Okay. And it meets our profiles. I think the rail can go beyond the profile. I think it will work fine, but just to be tidy, let's do it this way. Let's make all the additional geometry, construction geometry, so the program doesn't confuse it and don't create a rail that goes around like that. We want only this middle section. Okay, this is the first one done. Now we need a plane that goes through a point. I want point and parallel. Do we have something like this? Axis per, no, it's axis. I want plane. 3 points, mid plane. And maybe I can do offset plane. And no. Offset plane, not angle, tangent, plane. 3 points. Okay, but I can, what was it, 5.5? 5.5, so I can do this 5.5 divided by 2, and I can do again minus 5.5 by 2. Okay, this will work. Less urgent, non-adaptive, but it works. Like that. Okay, here's our second rail and the third one. I think we can just project this one. Yeah, saved ourselves a little work. Okay, so we now have our profiles and our rails. Let's save before we do the operation in case everything crashes. Yes, okay. Now we can do loft. So profiles, this one and this one. Okay. And now rails, this one, this one, and this one. How does it look? Pretty nice. Like how it looks. Okay. Let's see. Pretty nice geometry. Everything looks even, everything looks nice. Let me just see. Okay. So this worked out pretty great. Now we need to do this cut off here and punch out all these holes. Do this cut here. I think we can do that right now. I want to modify this to make it a little easier. Like that. Also here. Okay. And now we can use it to extrude all those agents. Okay. Let's do cut, let's do symmetric, let's do or. Let's see. Very nice. Now let's do this flat blade that's here. So we will maybe we can use the plane that we made, this one, create a sketch. Maybe let's hide the body. Let's project those agents. Like that. Now we can cut all those places and go to the middle plane. So here do the cut and the offset is minus this thickness 1.5 divided by 2, like that. How does it look here? Is it this shape? It kind of is. Right here. Now let's mirror that. Oh, not like that. But not adjust, but identical. I think will work. And it does. Let's check the measurement. It should be 1.5. And it is. So everything worked out great. We have this back blade done. Very nice. Very nice. Okay, so now I think we can do the front blade. Let me see how I want to do this. Okay, I have an idea. So first, let's maybe let's save first of all. Okay, and now let's edit this. Let's add a line here. So we have two different. Also, let me see. We want to also cut off this like that. So we have one profile, second profile, and third profile. They are all independent now. Okay. So now we want to extrude this one, let's say. We want to do new body, okay. New body, symmetric, and the distance is here. Six point 6.3, like that. Okay, and now we want to tilt this face down until we have and does it even tilt down? It does a little, but there's this. Okay, let's do this another way. Let's start with this one. It will be a little easier to make. Okay, so this dimension that we extruded to in this corner stays, but we want this plane to tilt down. So here at this place we have a dimension. Now it's 6.3 and we want it to be around to 8 or to maybe let's do to 4. Okay, so we want to, I think, move. Let's rotate. Oh, also another thing. Okay, we need to modified it a little. This line needs to be at a different angle because we are moving, rotating from this to here. So this line needs to be parallel to this direction because this is an axis that we rotate around. Like that. No, he lost it. Okay, like that. And now when we tilt this face, we have a nice bodies, but faces. So this face, and we have nice axis here around which we can rotate. Okay, so now the pretty hard part to find an what do you call it, angle around which we want to tilt this face down. So maybe let's see, maybe let's do a little guide here and just to help us do it a little quicker, like that. And the dimension is 2.4. Okay, and now when we rotate it, we're below the line, so 5 is way too much. Let's try 2, too little, 2, 5, and that looks around okay. And this dimension actually will be here, so let's try 2, 5. Let's also do the other side. -2.5. And now we can check the dimension. Oh wow, we're really close. Let's decrease the dimension just a little tiny bit. So let's maybe try to 5 here and here. Too much. So between 2.5 and 2.5, let's try 2.8 maybe. 2.8. 2.8. It's a pretty crude method, but it works pretty well. Gets you in the ballpark at least. 276. So let's try maybe 249. Two for 6. So wait, so we are moving in the wrong direction. It should be 2 for 7. 2 for 7. 2 for 7. 2 for 9. I'm happy with that. 8 microns this way or this way, doesn't really matter. So now you can see we have this nice tilt down, just like we have on this part, like that. Now we can do this part the same way. The difference here is that there is also this rounding of here, the sound of here, but it's much less critical than the one here. See how wide this one is here? So here it's really hard to pick up the dimension. We can only use it, we can do it kind of roughly, and here we can pick up the dimension much better, but we have no way to reliably pick up this place in the program. So let's see. How I want to do this. Maybe let's try to recreate this profile. Or actually, let's actually do it different way. The difference here is that when we tilted this, we have these three walls here that tilts all together. But here we have only one wall, so we can extrude it, and we can create this profile on this side and extrude it through, cut through. I think this will be better. So let's do this way. Okay. Let's extrude this. Distance to object to this point. Symmetric. Join. Okay. The way we the reason we didn't extrude both of those walls at the same time is because if we would, then when we would tilt this wall, this one would pick up, would also rotate around this axis in a in the other direction. This would go down, and this would go up. So to have them both independently, we finish this one, and now we are adding this one. And even if we would want to tilt this one the same way, they are both now different faces because they are at a different angle to each other. So that's why we wanted all those three regions independent to work with one at a time. So the things we do to the one don't also affect the others. Okay, so now we can create this profile on this wall, and the profile is actually this one. Okay, so let's rotate it a little. It goes like this. Here's a straight line. A line. Then we have an arc. And then we have again straight line. So it's a little similar to the profile on the other side, on the other blade, but it's not exactly the same. Like that. Okay, tangent. This one goes on. Oh. This one goes here. This is mirrored to this. Like that. That's perfect. Okay. This will be now a little easier. This and this to this, this and this to this. No, come on. What is it? Oh, it's the center. Okay, so not this one actually. I wanted to this. Okay, like that. That's what I wanted. Let's constrain everything to be sure that it won't move on us. Almost had it. Why doesn't it want to move? Oh, there we go. Okay, and now let's do some rough measurements. This is around. Trying to be as precise as I can, even though I can't pick up the perfect dimension. Trying to be very precise. 215 will be good enough. 2.15. The dimension from here to here is roughly 3.55, and the last one, this is roughly, wait, which one I checked? This one? Yeah, this one, it's okay. And this one is roughly 575. 575. And here is our profile. Now we can cut off those sections like that. Something probably, oh no, maybe not. Okay. What is that? Oh, the we don't need that. Okay. Now the last section is this, which is something with 4. I seem to remember 2.4. Let's make sure it was this one. 2.4. Okay, so we can even do this to object to this point. Symmetric drawing. Very nice. Let's get rid of that. Delete. Delete. Very nice. Here everything met very well. Okay, what is that? Sketch 9. What is the sketch 9 for? Did we lose something? No, I don't think so. Ah, it must have been some lost sketch made by mistake. Okay, so let's export our progress. Export, and we will have to I set the stream pretty soon. Why the oh, okay, those are points. I thought we have two concentric circles there, but those are just points. Okay, so let's again, to not be cut off middle of a sentence, let's restart the stream. So give me again a few minutes, and we will finish this part, I think, within the next hour. So give me a moment, reload the stream in a few minutes, and we'll be back. Okay, looks like we are. So let's continue. We have the parameter around this blade and this front blade done. So let's quickly extrude this middle part. The extrusion is pretty easy, but to find out this thickness, this dimension, will be a little bit more complex. The problem here is because this blade is thicker than this middle section, we can't grab it with calipers, because if we do it like that, we keep grabbing the parameter and not the middle section, which is thinner than the edge. So a good way to find this out is to do dimension, to take dimension off with two steps. First, we can measure this thickness, which we already knew. So in program we don't have to write anything. We can just where was it? No, again, we can just tell the program to extrude to this, but to start before it .6 millimeters. So minus 0.6, and you can see that we are below. We also want it to be done to the second, to the other side, same way, like that. Wait. What? Why 6? Why 6? .6. Oh, it's because of this thickness. This dimension is something wacky here because of the tilting we did. Yeah, 2, 4, 9, 2. Yeah, okay. But the difference, so this to this, this to this, is our 0.6. So as we wanted. So this front is done, pretty easy, and the only thing left to do is this middle section, which again will be pretty easy. Oh, we also have this this round of here, so this section. So let's maybe do that first. And the way I want to do this would be, let's see. Oh, the lower section, those cut-offs are also rounded off. Okay, so we want to draw those two profiles, and we need a plane that's parallel to the direction in which we will be extruding those. So let's maybe edit the sketch. to not create any new sketches unnecessarily. We will start here, perpendicular. Okay, we can even make it construction so it doesn't cause any problems. Okay, and now we can make our plane at an angle. Okay, let's make our sketch here like that. We can hide this one for now so it's easier to see. Let's make sure that I know how this profile looks. Okay, so we have two circles, this one and this one. They are concentric. And no. God damn it. Come on. From here. Okay. Like that. Now the middle of the bigger one is at this and this. Okay, the middle of the big one is at this point, the middle of the smaller one is at this point. Okay, this line is at this point, which is this point, so we don't need to even project. Midpoint, this to this. Okay, now we need to find out our thickness, which is this, and it will be 4. Let's do 4.9. 4.9. Okay. Also, I want to make sure that it's flat here. And the same way here. can get rid of this section, this section, this section, and this section. We lost some constraints. Let's see, what did we lose? For 9. Okay, so this will be our extrusion, and we start with the big one, and we extrude it right to here. I think it's like that. So no, to here. Or we can even do here, doesn't really matter. Okay, so to object, like that. Everything lines up properly. Okay, let's edit this real quick. We want to section of this region. Now we can cut off all of this. All symmetric. Okay. Now we have the teeth cut out, and now we just need to add the middle core. So again, extrude. And I think, oh no, we go past that last tooth. So we again go to this plane. I thought we maybe end at this last tooth and here is a void, but no. It goes right to here. Oh, I know what I did wrong. Okay. So with this, we need to cut out a little more. We also want to cut out all of these sections. Like that. And now when we extrude, yes, now it looks as it should. Okay, let's continue. What do we have next? Okay, we can extrude this and this, but without the teeth. So we need to edit the sketch and section the teeth off. Edit sketch. We need to cut off all of that. Yeah, I know some things will break, but we will fix them in a minute. Oh, nothing actually break. I expected few things to generate differently, but apparently not. Okay, and we have our thickness already because it goes right to here. Symmetric, join. Okay. The middle section looks pretty. Wait, how did I? Because it looks pretty thin. It's around 275. It's not an accurate measurement, but it gives us a rough idea. One 657. So actually it's too thin. So we need to redo that. They are not supposed to be concentric, apparently. We need to give this dimension here independently. And it's supposed to be, this might be actually a little more accurate. So let's actually put the dimension here. It's a more reliable way to measure it in this case. 145. 1.45. On the other side the same. Yeah, they are slightly moved one to another. It looks a lot better now. It was definitely too thin. Okay, now we can move on to the circles, maybe. Here, I wonder if they are actually the same thickness. The front one is 585 and the back one is 585. Okay, so we can do them both at the same time. 5.85 symmetric. One more thing I didn't check. Yes, we need to change to whole length. It would be twice too thick the way we did it. Okay, how does it look here? Okay, so let's do that in a moment. Okay, so this and okay, we need to section again. edit. We need to section this off. Will something derail? No. So we need this and this, and because it's tangent to the surface we made earlier, we can do to this point. It will join nicely, and we want it to be symmetric like that. Okay. There's actually a way to check. It's not 100%, but it gives you a rough idea if these two planes are tangent. And the way to do this is to turn off the edges of the model. And you actually do this here, I think. I don't change it very often. Yes, we have shaded with visible edges only, and we want only shaded. And you can see that, for example, here, where we have hard edge, or maybe here, you can see that the color of the walls is different, so you can tell that there is a hard edge here and here, even though this is a different face, this is a different face, you can't see any line here, any change of color, any hard lines. That's because those two faces are tangent. So this is a quick and dirty way to change to check if you and the faces you made are tangent. Because with the edges you can read the model better, it looks better, and you can understand it quicker, but it kind of covers up things like this. Okay, let's see, what do we have left? This section, okay, this section. Okay, so let's do the pinholes real quick. This is 785. 785. Symmetric. This is 615. 6.15. Symmetric. And the last one is 115. 115. Oh. Yeah, that's definitely not correct. That's why you want to keep looking at your part from different angles, because there are some mistakes that you might not see from only one certain angle. Okay, I'm pretty sure that all those sections, this one, this one, this one, this one, and even the centers of the circles are on the same level. They look like this, and even if there's a small difference between them, it doesn't really matter. But even when I look at them from a side, I can see that they are all at the same angle. So I'm not going to bother to check. So let's just quickly clean this up. Yes, it looks like that. The other side also. It won't work like this because we have another face here, so we need to get rid of those two. Nice. Let's export real quick. Okay, and the last thing to do, almost the last, those sections. So again, we want to extrude them. That's pretty self-explanatory, pretty easy. But again, the way we want to check this distance is pretty tricky. Fortunately, we have this pretty big area here that we can again check like this, and we can extrude to this wall and subtract the distance between them. But suppose we wouldn't have this big area here. If we would only have these little tiny places in some other part in which we can't reliably fit the blade of the caliper, what would you do then? There is a method I kind of came up with for this that I want to share it with you. You need a thin, rigid, hard object that can fit in those places. Ideally, you would have a little ground rod that's very stiff, that's hardened, that's stiff. That's the most important part. But realistically, you can use something like a sewing needle. The sharp tip here is pretty disadvantageous. You would ideally want to have a flat surface here, so you can ground off the tip, but you can even use a needle with a sharp edge, a sharp tip. The first thing you want to do, no, my batteries keep dying. Okay, first thing you want to do is to measure the length of your pin, your needle, and the very important thing is that it's perpendicular to the blades of the caliper. Ideally, you would want a little thicker object with flat perpendicular edges at the ends, but with this kind of work you don't really need this precision. You can just align the needle, make sure that it's in the right place, and it will work well enough. Okay, and now what you want to do with that dimension picked up, whatever it is, it doesn't really matter, you want to zero your calipers. And now the length of the needle is 0. So now we can take the needle. This is why you want the sharp point here, because if you put it at a part and you squeeze it with calipers very hard, you can penetrate the part and you change the dimension. That's why you want a flat plane here. But what you can do, you can flip it around with the blunt end to the part. The needle won't penetrate the hardened steel of the calipers, so it works fine. And what you want to do is you want to put the needle on the face of which you take the dimension. I don't know if you will be able to see this, but I use the needle as the blade of the caliper. So I rest the needle on one of the planes I want to measure, and now I rest the blade of the calipers on the other face I want to measure, and I rest the calipers on the edge of the needle while keeping everything parallel and straight. and with a dimension taken like that, you can see that dimension is y 1.98, so around 2 millimeters. It's a very good method that you can use to reach all those hard places. And remember, the most important thing is that the object you are using is stiff, that it doesn't bend. Needles are hardened, so they are very good for that. And if you want to make a measuring needle that you will be using regularly and you want it to be reliable, you ideally would want to ground off the sharp tip and make sure that both ends are as parallel as you can do. The best way would be to clamp it in some machining tooling and precision grind of the tips, but again, for this kind of work, it's not really necessary. So now we know that the distance between our face and this face, because I rested my end of the calipers, this point on here, I could have also used this face, then the dimension would be different, and I know that we want to go below this face 2 millimeters. Some provides for to create and bodies. What? Oh, we have some problems here. Okay, we will address this in a moment. Okay, and we want to, as always, do this symmetrically, like that. Okay, let's double check. From here to here, 2 millimeters. The other side, here to here, 2 millimeters. Perfect. Oh, it did generate. I think it changed when I clicked symmetric. It couldn't generate before it was symmetric. No idea why, but it's good that it works now. How do they meet here? Oh, wait. Yes. So this actually like that. And now we will be able to delete this. Yes, this is how it looks actually. Okay, so we don't need to actually go back. Everything generated very nicely. Now all our loose bodies. Oh no, not all. What? What happened here? Why they are? What the hell happened here? Okay, so now we have 3 bodies. That's okay. Now we still have 3 bodies. Okay. 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 So what's the problem here? That's weird. But yeah, that's what we wanted. 1 body. So no idea what happened there. I think I'm running pretty low on memory. I can feel the laptop getting pretty hot with the modeling software, with the steaming software. I'm recording simultaneously, so it's no wonder that the computer doesn't well, it gets lost sometimes. It has some problems sometimes. No wonder. Okay, so last one thing to do is to add a base right here for the axle and the axle itself. So we can move the pin away. Okay, as the axle is a precision, what do you call it? Precision feature of this part, I actually will be using my standard dimensions, so I won't be taking any more dimensions. Let's see. 7.4 is the diameter. We don't want to risk taking the dimensions wrong from the part and then have the axle or the pinholes not fit other parts. So when it comes to this precise stuff, you want to be sure that you are making it correctly. Okay, that's one thing, and the other, okay, 182. 182. Half of this. 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 The diameter is 478. 478. Trim the excess. Like that. Maybe even this. What's the problem here? Oh. And the dimension? Okay. Happy. Finish. Extrude. This. Dimension is 775. Okay. let's make sure that we did everything correctly. We did. And the last thing are the fillets. 85. 0.85, and these ones 0.8. 0.8. Okay. Let's see. Did we miss something? Oh, we did. We're not supposed to have a hole here. Okay, so this is a one thing. Let's keep checking. Did we miss something? Everything looks great here. Looks great here. Like this. Okay. Oh, what happened here? That's why you need to check your pad from all the angles, from every side. Make sure everything is okay, nothing weird. Very nice. Really happy with how this pad turned out. Okay, so I think that will be all for today. Let me just check. Okay, I think we can finish the stream like that. Just to reiterate all the things I said previously, I still want to open the shop as soon as I can. No idea when it will be. Even if I open it soon, it might be closed again soon, so I might only open it for some short period of time. Sorry that I haven't been posting a lot of stuff lately. It's really hard for me to make myself to make anything creatively. I've been doing some other stuff on the other account, on the AFC Adam Filip Creations account. So if you want to keep track of what I'm doing, you can also visit that account. But the Bionicle content had a big pause recently, and I'm not sure if I will pick it up again soon. So that's kind of how it looks. I hope I will be able to do some interesting stuff again soon, but it unfortunately is not entirely dependent on me. There are some other stuff happening in life that you just have to kind of adapt to, and yeah. So we'll see when the shop opens, if the shop opens, for how long the shop opens. As long as for the post, we'll see if I will be able to post some more stuff. Again, just be patient. If you want to follow me, if you want to see the stuff I make, you just have to be a little patient for the time I have some more abilities to do this kind of stuff. But in the meantime, I'm still active, kind of active on all the social media. So if you want to contact me, if you want to ask for anything, you absolutely can. And just until I do something again, I wish you all a great day, great time. Be safe out there, and I'll see you until the next time. Bye guys.